Good afternoon, class. We are looking at the final exam review covering from 1.6 to 5.4. We've covered a big chunk of it. Here's the second part. We are looking at integration using substitution. The integral of ln x to the power of 2 over x dx. Anytime ln x is involved, that's the choice of you. Its derivative is 1 over x, so du is 1 over x dx, or you might say dx over ex, dx over x. It's a good practice to rewrite it so it becomes clear what we are dealing with. We are dealing with u squared du, which uses the power rule, so you get 1/3 u cubed plus c, and u is replaced by ln x. We are done. Anytime you have a fractional format, after you put it in lowest term, you ask yourself, if I choose u to be the denominator, I hope you recognize that derivative is the numerator. So e to the power of x, the derivative is e to the power of x, plus e to the power minus x, the derivative is minus e to the power minus x. Therefore, if the numerator is the derivative, the numerator times dx is du. And you rewrite this by putting the dx next to the numerator, simply because dx, dt, all of them, if you happen to have dx, dt, d theta, they belong to the numerator. They never belong to the denominator. This is the integral of du over u, a simple case of a natural log, and replacing the u with the expression e to the power of x plus e to the power minus x. ln of absolute value of e to the power of x plus e to the power minus x. You can lose the absolute value because this expression is positive. Otherwise, you can't. Notice this, in this integration, theta is the independent variable. 5 gives you 5 theta. 2 cosine theta gives you 2 sine theta plus a constant. Anytime you have an exponential, the exponent is a choice of u. So u is x to the power of 5 minus 2. The derivative is 5x to the power of 4, which makes du 5x to the power of 4 dx. We are going to move x to the power of 4, so it becomes clear everything is in order except number 5 is missing. You have two choices. You can solve for dx, or the easy way out. Since 5 is a number, put it in there, undo it with its reciprocal. And so now you're dealing with 1/5 e to the power of u du. The integral is itself, so 1/5 e to the power of u and a constant, and the u is replaced. We get 1/5 e to the power of x to the power of 5 minus 2 plus a constant. And as always, if you differentiate, you get this expression without the dx. You have a natural log, and you're integrating. That is a choice of u. The derivative is 1 over x plus 1 times the derivative of the inside, which is 1, or simply 1 over x plus 1. That makes du 1 over x plus 1 times dx. So we can rewrite this so it becomes clear that we are dealing with u and du. And as far as the limits are concerned, the original limits are different now. We are going to put 0 in here. We get ln of 1, which is 0. But when you put 1, you get ln of 2, which is different. As you know, the integral of u is half of u squared. And we're going to go from ln 1, which is 0, to ln 2. This has no bearing. When you put ln 2, the final answer becomes half of ln 2 quantity squared. And you keep it as such because it's an exact answer. We are dealing with the sinusoidal functions. In this case, the argument x squared has an exponent, and therefore x squared is a choice of u. Its derivative is 2x. Du becomes 2x dx. We rewrite by moving the x next to dx, and when we compare to du, everything is in order except 2 is missing, because 2 is a number. You can throw in the 2, undo it with its reciprocal 1/2. And now you're dealing with 1/2 sine u, integral of sine u du, which gives you, sine gives you negative cosine, so negative 1/2 cosine u and a constant, and the u is replaced with x squared. Anytime sine and cosine both are there, you choose the one that has the exponent as u, but without the exponent. So therefore, u equals sine x. Its derivative is cosine x, and du is cosine x dx. So you're dealing with u squared du, a simple case of a power rule, 1/3 u cubed and a constant. You replace the u and you're done. What about this case? The integral of cosine to the power of 20 of x, sine x dx. Cosine is the one with the exponent, so that's a choice of u. U equals cosine x, everybody. So what is the derivative? Negative sine x. Therefore, du is negative sine x dx. Now, notice this one doesn't have a negative sign, so you can plug in, negative out. So you're dealing with negative integral of u to the power of 20 du, which makes it negative 1/21 u to the power of 21 plus a constant, and the u is replaced with cosine. We get negative 1/21 cosine to the power of 21x plus a constant. Many fish grow in a way that is described by von Bertalanffy growth equation. For a fish that starts life with a length of 1 centimeter and has a maximum length of 30 centimeters, this equation predicts that the growth rate is 29 e to the power minus x centimeters per year, where x is the age of the fish. How long will the fish be after 4 years? Round your answer to 1 decimal. If capital L of x represents the length of the fish at any age x, then this is L prime of x, or dl dx, with the initial value L of 0 equals 1. The accumulated change theorem says the amount of increase after so many years is the integral of 0 to that number. So the integral of the growth rate, 29 e to the power minus x dx, from 0 to 4. The integral is negative 29 e to the power minus x. You plug in 4 and 0. Although e to the power of 0 is easy and becomes 1, you really have to evaluate this one using a calculator. It ends up being 28.468 with a bunch of decimals, and L of 0 is 1. That's the initial value that has to be added. They ask for 1 decimal. So 4 and next to it is 6, goes up to 5, becomes 29.5 centimeters. Now, one other way is to find the definite integral and use the initial value to find the constant. So since this was done here, the answer is this one, plus a constant with L of 0 equals 1. If you replace x with 0, L of x becomes 1. This is 1, so negative 29 added to what number to get 1? The answer is 30. We want after 4 years. So all you have to do, plug it in here, and that gives you the same answer as this one. Of course, we do the rounding accordingly. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? When you have 2 points in time, it's the average velocity, which is total distance over total time. So that makes it s of 4 minus s of 2 over 4 minus 2. We're going to plug in 4 here. 2 times 4 is squared minus 5 times 4 plus 40 minus. We're going to plug in 2. 2 times 2 squared minus 5 times 2 plus 40. And the denominator is simply 4 minus 2. Simplification will result in 52 minus 38 over 2, which is 7 meters per second. This is the average velocity from 2 to 4 seconds. What is the instantaneous velocity and the acceleration? If you differentiate this, you get S prime of t or V of t, which is 4t minus 5. We want the velocity after 6 seconds. If you replace the t with 6, you get 4 times 6, 24 minus 5, or 19 meters per second. We want the acceleration. By definition, acceleration is the second derivative of the position function. A of t is v prime of t equals s double prime of t. That means differentiate this one again, and you get a constant of 4. Because it's a constant, it doesn't matter after 6 seconds, 5 seconds, 2 seconds, still the same thing. As far as the units are concerned, A of t or dv dt, the units of the velocity is meters per second. The units of time is seconds, and this results in meters per square second. When does the object reach a velocity of 31? You set v equals 31. You move the negative, becomes positive 5. 36 divided by 4 results in 9 seconds. Use differentials to approximate cube root of 63.5. First and foremost, we need a function to represent this. So look at the operation. The operation is taking the cube root, so cube root of x. Then you read a number. Choose an x to be a number close to 63.5, for which the cube root is easy to compute. Of course, that is 64, because everybody should know cube root of 64 is 4. So that results in dx or delta x being 63.5 minus 64, or negative 0.5. It's important to know the meaning of that. We know the cube root of 64 is 4. We don't know the cube root of 63.5. And this negative indicates it will be less than 4. Whereas if, for the sake of argument, we were interested in cube root of, let's say, 65, then dx would be 65 minus 64, which is positive 1, which means we may not know cube root of 65, but it's larger than cube root of 64, larger than 4. That's the concept. So we are going to go with f of x plus delta x is f of x plus delta y, and delta y is approximated by dy. So do we have f of x? Yes. Do we have dy? No. How do we find it? First and foremost, let's find f prime of x. To do so, we're going to change this to x to the power of 1/3. Its derivative is 1/3, x to the power of 1/3 minus 1 or negative 2/3, which makes it 1/3 cube root of x quantity squared, and dy is the same thing times dx. Now plug in f of x is cube root of x, and dy is dx over 3 cube root of x quantity squared. You want cube root of 63.5. That means you want f of 63.5. That means x is 64, delta x is negative 0.5. So in this equation, replace the x with 64 and dx or delta x with negative 0.5. This is obviously 4. This is 4. Squared is 16 times 3. This is, which makes it 48. I'm going to change the numerator to 1/2. So you notice this complex fraction is 1/2 times 48, or 1/96. And the answer is 3/95/96. This is, with this process, of course, it's an approximation, but this is easy to calculate even without a calculator. If you put it into a calculator, you get this one. And the calculator value actually will give us something close to that. This is what we've approximated. And notice if we stop here, we have to round it because of 8, because becomes 6. And if we do the same thing, we get number 6 here. So they are pretty close because dx or delta x is fairly small compared to the choice of x. Here's a different method, linearization, which means finding the tangent line. And you don't have to memorize that. Just follow the point slope. So you have to find the tangent line. You need a pair. X is 64. Plug it in. That gives you 64, 4. That is the pair. You need the slope. F prime is not the slope. If you plug in 64, remember, the denominator here was 48, so 1 over 48. Y minus y1, that means y minus 4 equals m, 1 over 48. X minus x sub 1, that means 64. And you simplify, you get this one. This is L of x. So what do you have to do? Plug in 63.5, and it will give you the same answer if you go with 63.5 and work it out. With fractions, you get exactly 3 and 95 over 96. That's why I wrote that. It is easier to get that without a calculator. Find the absolute max and mean values of f of x in the given interval, where f of x is x to the power of 4 minus 18x squared, and the closed interval of negative 4 to 1. We're going to use the closed interval theorem. First and foremost, let me remind everybody what is a polynomial. F of x, or sometimes they call it P of x, is a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0, where a sub n can't be 0, and all of these exponents are whole numbers. Whole numbers are 0, 1, 2, to infinity. And in that case, any polynomial of any degree has a domain of negative to positive infinity, which means it's continuous from negative to positive infinity. This is a polynomial of degree 4, and therefore it's continuous from negative to positive infinity, which makes it continuous in the given interval. Therefore, we can use this method. We're going to start looking for CPs. In order to find critical points, we find f prime, which is 4x cubed minus 36x. To set this equal to 0, we're going to factor the 4x out. We get x squared minus 9. To continue, x squared minus 9 becomes x plus 3x minus 3. Set this equal to 0. X is 0, x is negative 3, and x is positive 3. Also, we're going to look at f prime d any or does not exist. That doesn't produce any solution. This is a Greek letter phi, as you recall, which represents an empty set, meaning f prime itself is a polynomial of degree 3. It exists everywhere. So those are the 3 possible solutions. We have to look at the given interval. Is 0 in between? Negative 4 and 1, yes. What about negative 3? Yes. What about positive 3? No, it's larger than 1. So this is out. We can only use those 2. That means we are going to go back to f of x, evaluated at the endpoints as well as the critical points. I hope you recognize 0 is very easy, gives you 0. 1 gives you 1 minus 18, which is negative 17. Negative 4 gives you negative 4 to the power of 4 minus 18 times negative 4 squared. Negative 3 gives you negative 3 to the power of 4 minus 18 negative 3 squared. And when you evaluate them, you get those values. As you can see, all numbers are negative except this one. So the absolute maximum is equal to 0 at this pair. Absolute minimum is equal to this at this pair. So absolute max is 0 at 0, 0. Absolute minimum is negative 81 at negative 3, negative 81. We want to evaluate the integral. We have a polynomial of degree 1 here, polynomial of degree 2 inside the radical sign. So that's a more complicated one. The choice of u would be 25 minus x squared. Its derivative is negative 2x. So du is negative 2x dx. We move the x, so it becomes clear everything is in order except negative 2 is missing. You have two choices. You can solve for dx, or because negative 2 is a number, plug it in and undo it with its reciprocal. So this is u to the power of 1/2, and this is du. And so negative 1/2 square root of u, or negative 1/2 u to the power of 1/2 du. And we're not going to write the limits yet. We're going to figure it out in a moment. This is 1 over 1/2 plus 1 u to the power of 1/2 plus 1. And as you know, this is 3/2. The reciprocal is 2/3. The product is negative 1/3. So negative 1/3 u to the power of 3/2. We go back to the original variable x, original limits 3 and 4. Or if you plug in 3 here, you get 9. 25 minus 9 is 16. If you plug in 4 here, you get 16. 25 minus 16 is 9. And those are the limits we are going to use. We put the negative 1/3 outside, and we're going to plug in 9 and 16. So 9 to the power of 3/2 is square root of 9, or 3 cubed 27, minus 16 to the power of 3/2 is square root of 16, or 4 cubed 64, results in negative 37. The product of negative 1/3 and negative 37 is positive 37/3 as the final answer. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area of a cross-section of the vessel. Cross-section is in the circular shape where A is pi r squared. So we have the radius of 1.4 to begin with. So this is the original radius. And now this is a new radius, which is smaller. The original one is 1.4. The smaller one is 1.3. And here's the difference, which is dr, or delta r. So r is 1.4. Dr is the difference of the two, 1.3 minus 1.4, which makes a negative 0.1. Area is pi r squared. And we want, what do we want? We want to approximate the change in the area, the shaded region, the shaded area. We want to find it by approximation, which means finding dA. Since f prime of x is dy dx, then a prime of r is dA dr. I wrote that so we can see the transition. And therefore, remember, dy is f prime of x dx, dA is a prime of r dr. And so to do so, we are going to find a prime of r, or dA dr, using the fact that a equals pi r squared, and dA dr, pi is a number, r squared becomes a 2r, and therefore dA dr is 2 pi r. What is dA? A 2 pi r times dr, and r is 1.4, the original radius. Dr is negative 0.1. If you keep it as a pi, you get negative 0.28 pi millimeters squared. If you change it to this one, this is what you get, but stick with the exact answer. And we're done. However, what would be the exact change in the area? What would be the shaded region? Well, the area of the small one, which means pi r squared, 1.3 squared, minus the area of the larger circle, that means pi r squared is 1.4 squared. Their difference is the exact answer. And as you can see, these two are pretty close. A farmer with 200 feet of fencing wants to build an E-shaped enclosure besides a creek as seen in the diagram, find the maximum area that can be enclosed. Anytime you have a word problem, you have to have a setting. The setting is given to you. If not, you have to make up one. And you have to define your variables. So X represents the width, Y represents the length, A is the area. We want to maximize the area, which is X times Y. What is the constraint? It's subject to 200 feet of fencing. Normally we have X and X2, but we have here 1, 2, 3X. Instead of 2Y, we have only 1Y. So 3X plus Y is 240. A is a function of two variables, X and Y. So you solve for Y. You plug it into this, and A becomes a function of X. If you multiply, you get 240x minus 3x squared. And X is between 0 and 80. The reason is X is a dimension, must be positive. And the reason it's less than 80, if you set this one equal to 0, X becomes 80. What happens if you choose a number larger than 80? This expression, which represents one side, is negative. We can't have it. The area becomes negative, and that's out. So what do we have? We have an open interval of 0 to 80. We are going to find the critical point or points by differentiating. We get 240 minus 6x, setting it equal to 0 results in 40. We have one critical point and an open interval. So local becomes absolute. We go with the second derivative test because it's easier to differentiate again. We get -6. Remember, the second derivative test says you have to plug in. But because it's independent of X, regardless of what X is, this is always negative. It makes it always concave down, and therefore maximum occurs when it's concave down at X equals 40. You put that into either this or this equation, Y becomes 120. What is the maximum area? The product of the two is 4,800 square feet. Whenever we have a rational function or any fractional format, the very first thing is to simplify if you can. The denominator can be factored into 2x plus 3 times x minus 1. Doesn't help us. So fractional format or rational format, after it's simplified, u would be the denominator. Its derivative is 4x plus 1. Therefore, du is 4x plus 1 times dx. We put the dx at top. So it becomes clear that we have du over u, and the integral of du over u is a natural log and a constant. Replace the u and make sure to keep the absolute value. The answer is natural log of absolute value of 2x squared plus x minus 3 plus a constant. However, in part B, you can factor the numerator as well. And x minus 1 drops. Now, because it can't be simplified any further, u would be the denominator of 2x plus 3. Its derivative is 2, therefore du is 2 dx. And you notice dx belongs to the numerator, so the numerator is 4 times dx instead of 2 times dx. So you can cut it into two pieces, 2 times 2 dx. So this is du over u, and this portion is just the same as this portion. The answer is a natural log, and you replace it, and the final answer is 2 natural log of absolute value of 2x plus 3 plus c. In both cases, you have to keep the absolute value because the expression may be positive or negative. What I want to do, I want to look at the reciprocal of this, and therefore I'm going to get the reciprocal of this, which is 2x plus 3 over 4. I'm going to make up two fractions, this one, half of x, this one, 3/4. The integral of x is half of x squared. With this 1/2 becomes 1/4 x squared. This is 3/4 x and a constant, meaning there is no need for a substitution here. That's why it's important to see Compare and contrast these three questions next to each other. This can't be simplified, this can, and this doesn't require substitution method. A bacterial colony has a population of P of t equals 20t over 10 plus t squared in millions t hours after a nutrient is introduced. Use differentials to approximate the change from t equals 2 to t equals 2.4. So t equals 2 and dt or delta t is the difference between the two, which is 2.4 minus 2 or 0.4. And since we want the approximate change, we want dp. So P of t is given. If we find P prime of t, that means we find dp dt, and dp would be the product of these two, P prime of t dt. So first and foremost, let's find dp dt or P prime of t using the quotient rule. So I'm going to call this f over g, and we need f prime g minus g prime f over g squared. So f prime is 20 times the bottom 10 plus t squared, or g, minus g prime is 2t times f or 20t, and the bottom g squared. Just put it in a parenthesis and square it. This has to be simplified by distributing and then combining. We get 200 plus 20t squared minus 40t squared, these two combine. And this is P prime of t, or dp dt. So what is dp? The same thing times dt. If you replace the t with 2 and dt with 0.4 and evaluate this, you end up with 0.245 million bacteria. Now, if you want to find the exact, you find delta P, which means plug in 2.4, P of 2.4, evaluated. Plug in 2, P of 2, evaluated. And the difference is the answer. And it's important to understand this means 245,000. This means 189,000 bacteria. That's the meaning of it. G of x is 1/2 x plus 3 for x less than -2, and it's x minus 1 for x greater than or equal to -2. This is a piecewise defined function. Is g of x continuous at x equals -2? Why or why not? First of all, reminding everybody as far as the continuity is concerned, when the limit of f of x as x approaches a is equal to functional value f of a, the function is continuous at x equals a. The one-sided limit says a function has a limit at a if the limit of f of x as x approaches a from the left and x approaches a from the right, they are identical, the limit exists and is equal to a. I hope you recognize the top piece and the bottom piece, both of them as linear functions. And they both have a domain of all real numbers, and the only thing we have to check is the endpoints, which is -2. So the function has a value where we have the equality. So we're going to evaluate this at -2. If you plug in -2, you get -3. Then we want a left-sided limit. We have to go with the less than and evaluate this one at x equals -2. And the notation is the limit of g of x as x approaches -2 from the left is half of x plus 3 such that x equals -2. If I put -2 here, divide by 2, -1 and 3, they add up to 2. The right side limit where x is larger than, and this is larger than or equal, that's why we use it for function, and we're going to use it for the right side limit as well. The limit of g of x as x approaches -2 from the right is x minus 1 such that x is -2. If you plug in, you get -3. So what happens? The two limits, the left and right, are not the same. The limit doesn't exist. So the limit of g of x as x approaches -2 from the left is not equal to the limit of g of x as x approaches -2 from the right. Therefore, the limit of g of x As x approaches -2, dne does not exist. Therefore, g is not continuous at x equals -2. What I want you to notice is that these two numbers are the same. What it means is the following. G of x is continuous at x equals -2 from the right. Because the functional value and the right side limit, they are equal, this is what we say. Needless to say, this doesn't change. It is still discontinuous at -2. However, you can say it's continuous from the right. Given the graph of a function g, state the values, if they exist, of the following. We want the limit of g of x as x approaches 2. That's why we look at it from the left and right. So from the left of 2 here, from the right of 2 here. So as we approach the function from the left of a 2, we end up with the y coordinate of 3. From the right, we end up here with the y coordinate of 1. Since they are different, the limit does not exist. We want the limit of g of x as x approaches 5. That's why we're going to look at it from both sides. Here's number 5. Here's the left side of number 5. Here's the right side of number 5. So as we approach 5 from the left and from the right, in both cases, we are moving towards this hole, which has a y coordinate 2, and therefore, because the two sides have the same limit, the limit exists and is equal to 2. If we assume this is a y coordinate 1.4, that means g, the functional value at x equals 5 equals 1.4, which is not equal to the limit. Of course, it makes it discontinuous at x equals 5 as well as x equals 2. However, there's a difference, and that is, here's the definition of a continuity. The limit of f of x as x approaches a equals f of a. So it's not continuous at that. G of x can be continuous at x equals 5 if we do what? Because there is only one hole, this is called a removable discontinuity. If we redefine g of 5 to be its limit, which is 2. However, there is a jump at 2, g of 2 is not given, but because there is a jump, there is no way to fix this. So this is a removable discontinuity. This is a jump as far as the terminology is concerned. We want to find the limit of this function at various numbers, and I want to give you the definition of a VA, short for vertical asymptote. The limit of f of x when x approaches a, or a from the left or a from the right, it's either negative or positive infinity, gives rise to the equation of x equals a being a vertical asymptote. So when x approaches 2, from both sides of 2, it goes to negative infinity. And when x approaches 5, from both sides, it goes to infinity. -3 is a different story. From the left side goes to negative infinity. From the right side goes to positive infinity. And that gives us the equation of a vertical asymptote, x equals 2, x equals 5. This says x equals -3, the same thing here. And so these are the vertical asymptotes at x equals 2, x equals 5, and x equals -3, according to this definition.